Okay, so yeah, hi everyone. Welcome to the Apache Pinot contribute core number 3. So today we are very honored to invite two speakers from Uber, Xin Gao and Shaurya. Sorry, I don't know how to pronounce your last name, but yeah, I'll let you introduce yourself later. So Xin will be talking about the Graceful node replacement in their cloud environment, and Shaurya will talk about the new Timeseries Engine GA, the features and the roadmaps. Okay, so we will start it with Xi, and yeah, we will let you try to share screen and I'll do something. Yeah.
Yeah. Thanks Xiang for introduction. So yeah, let me quickly share screen. Are you able to see the screen?
Yeah.
Okay, thanks. So yeah, hi everyone, this is Xin. So today I will talk about the Graceful node replacement. So yeah, the agenda is like first I will talk about the background about how Pinot cluster set up and node replacement happened in like cloud-like environments. Then I will talk about some overhead with the traditional node replacement methods. Then we will introduce the Graceful node replacement and touch a bit on what's next. So first, this is a kind of general Pinot clusters. So there are mainly three types of roles: controllers, servers, and brokers. There could be minions, but I didn't put it here. And for the replacements, our main focus is on the server because server is storing data and is most of the stateful components. And Pinot as like stateful technology. So unlike the stateless components, it has to do the careful node replacement. So usually how it happens is with all those instances in the cluster.
Sorry
We will,
to
yeah.
sorry to interrupt you, Shin. I just want to make sure that we're recording. Yes. Okay. Thank you.
Yes, you can see the recording icon on the right side, right after.
Yeah, sounds good. Yeah. Yeah, back to this replacement. So for the every instance in the Pinot cluster, they will have an instance ID. For example, controller, server, broker. This instance ID is unique, and all different instances will have their own instance ID. During the replacement, common way to replace the component is to find the new host with the same instance ID to replace it. Let's say we want to replace the server 2 instance. And how it works is kind of we bring up an empty new host, different host name, but same instance ID, server 2. And unlike the old servers, which is with a lot of segments, the immutable segments on the disk, the new host, we don't have the segments. It's an empty host. And when we replace it, we will use the new empty host to replace the server with segments. So then what's happened is like when the new host, here let's call the old host the old node, the new host the new node. They will be with same instance ID. So for the new host, the new node, during the start, it will register to the Helix cluster and then fetch the information from the Helix to get what kind of segments to add. And irrelevant, it can be offline segment, it can be real-time segments, and it will try to find if the segment is on the disk. If not, it will try to download it from either deep store or peers. After it's downloaded and loaded all segments to the memory, it will convert it to online or consuming, make it healthy and able to serve the traffic. So that's how it happened. But because of we are using a new node, the new node is not with those immutable on these segments. They always need to download segments from deep store. And Helix also give us a restriction that we are not, the new node cannot join the cluster before the all node down, because there cannot be two instances with same instance ID in the cluster at the same time. So the sequence of node replacement is, first, we need to shut down the old node. Then we need to confirm or acknowledge the old node is completely done. So only after that, we can start a new node with the same instance ID and let it join the cluster. And during its startup phase, it will try to download segments, and finally it will become online. Yeah, this is kind of like a cloud environment. You need to do this, and with that environment, this happens time to time. So almost with a large cluster, these things happens always. Then we'll come with the overhead of this issue. So first, downloading segments take some time, depends on your node size. Your nodes can be multiple gigabytes up to multiple or over 10 terabytes. With those kind of size, it takes time to download from deep store. And you also need to consider like deep store is not that stable. It may prolong the downloading time of the segments. Then your server will experience a long downtime. Because in the process, you need to always shut down your old node before starting the new node. All those downloading phase time taken is counted as server downtime. Although you have multiple replicas, you have to experience less replicas to serve in the query traffic. So let's say if you have 2 replicas, during that time, you only have 1 replica online. And during that time, you have high risk of single point failures. So let's say you are doing a node replacement, and with only 1 replica serving the traffic. But during that time, if there's some hardware failures, then you will have 0 replicas. And that's a high risk of failures. And also less replicas means like potential lower query performance. You may experience the query performance degradation. So that's the issue of it. And one indicator for this thing is, for example, helix pending messages. When you bring up a new node, the new node will always start with very high helix pending messages. Means that it needs to take those tasks to download those segments and make them online. So it usually takes time to download them depending on the node size. The time taken will between like 10 minutes or over 10 minutes to multiple hours, up to your segment size and how complex your segment it is. And this process could be pretty slow. And as we mentioned, this tens of minutes or hours interval will bring us a lot of risks to the system. Then the next question is how to make it fast, how to make it not too slow. But here we need to understand the real pinpoint. Is slow a really issue? But I feel like it's not, because in the real environment, the node replacement happens time to time, but you don't really care about how long the replacement itself takes. What we care about is the long server downtime. So let's say if the node replacement takes same time, but there's no server downtime, then it's not an issue for our system. There are no risks for the single point failure or query performance degradation. So what we need to solve is like this long server downtime issue to avoid this server downtime. Then let's analyze why there's a long server downtime. So server downtime, this kind of downtime is mainly from the downloading segments. Download segment is during the server initialization. And the reason we have to experience this server initialization is always after new node joins the helix cluster. We are relying on the helix to understand what kind of resource we need to download and convert to online. And the new node cannot join the helix cluster because before the old node is down. So this is the helix restriction. We cannot, they need to watch the same node, and we cannot have 2 nodes at the same time. But the next question is, why do we have to download segments before all node down? Why do we always need to rely on helix to know which segments we need to download? So the instance to segment mapping is in the zookeeper. It's not literally have to be through the helix. We can just use the information from zookeeper and download the data from deep store. There's no hard requirements in the design to always download by the same way as the server startup. So our answer here is pre-download. And I've attached the PR link and the open source document link. So the high level idea of this pre-download is like when you start a new node, so you do not need to register or connect to Helix. You just get segments name or info from the zookeeper. And based on those zookeeper information, you can use the same server config and Pinot libraries to download segments from the deep store. So with that being said, you can start server first to download all segments. After all segments downloaded, then connect, shut down the old node and connect the new server. So with that PR contributed, so right now we are able to do those kind of pre-downloading with just 3 lines of code. So there's a new package called pre-download scheduler introduced. And we just need to first load the server config in the same way as we did, and then start up the pre-download scheduler with the server config. Then we start up the pre-download scheduler. It will do best effort downloading for all the segments attached to the same instance. So the new process is instead of shutting down old node, then start up new node, we do starting up the new node in the pre-download mode. And then we complete pre-download mode to download all the segments we need. Then we shut down old node and start a new node in the old way. So this is the new end-to-end process that we can do to achieve this graceful node replacement, which means like the node replacements will not bring up any overhead to your system. It will be same as the node restart. Then if you want to achieve the full automation, this is a reference that your cloud-based system can use. So usually on your cloud-based system, you have an agent on the node to control the life cycle of your Pinot container. And first you need to, when you start a node or replace the node, you can first try to say if the pre-download is complete. So, and this pre-download, because it's by best effort, we can have 3, for example, scenarios of complete. First one is the full download succeed. Next is like max retry reach, or there's a timeout reached. So do the best effort pre-download. And once this is complete, we can stop the pre-down container and stop the old node, then start the new node. Start a node with the normal mode. Normal mode means like our current way of starting node. The reason mentioning this normal node because it's let's say for the pre-download we call mode pre-download, and in pre-download workflows, the pre-download scheduler will try to check the fetch the segment metadata and loop through the segment metadata to see like if all segments are downloaded. If not, it will download from HDFS and decompress till there's no segments left. So current implementation, it will record all the information onto the disk to see if the segment download succeed. Then your agent can try to fetch the file info from disk to see the pre-download status. And based on that status to go to the main loop to start up the container. So yeah, that's kind of a reference implementation file system to achieve this graceful node replacement in background. So yeah, I'll quickly share some impact. So right now, with this graceful node replacement method, the replace could be same as restart. And for the node with a small amount of data, for example, less than 1 terabytes, so the old replacement time could take like 15 minutes server downtime, but right now it could be transparent. We will not observe any high Helix pending message specs. And for the node with like multi terabytes or like very large node, then it can also reduce the server downtime significantly from hours to around 10 minutes. So yeah, this kind of make the replacement same as restart. But the 10 minutes because even the no restart will take some time for super large node. And yeah, that's basically all the pre-download we introduced in the Pinot, and at least a few what's next that we can improve this pre-download features. So right now the pre-download only focuses on the downloading from the deep store. It's not using the peer download to avoid the noise traffic on the peers, but we can introduce these things to make it more reliable. Second is relimiting. So right now the pre-download is tuned to be maxed out all the CPU and network I/O and disk I/Os to make the downloading speed at a fastest speed. But this might introduce some noise neighbor issue to your to the containers on the same host. So we could also investigate if we can do some rate limiting on the downloading speed. Next is runtime mode switch. So right now we need to have like two phase for the pre-download. We started the pre-download in the so-called pre-download mode. After pre-download, we start the node in the normal mode. But theoretically, it's possible to make this runtime switch. Let the server itself decide when it join the heated cluster by some retries. And last but not least, we can observe that for super large node, even with this Graceful node placement, it can be same as restart, but restart is still not fully transparent. There might be opportunities to reduce the no restart time to help the restart also reducing the server downtime. So yeah, that's basically the no replacement. So yeah, any questions?
Cool. This is a very useful feature. So to understand more, like so this is more like used when you have like unexpected node went down, or you are mostly using it for like expected like node rotation or whatever. Which scenario do you see it like happening more often?
I think both. So at least in our cloud-like environment, the node replacement happens time to time, and it's usually not controlled by our Pinot team. It's more controlled on underlying infra team. So they will, for example, shift the nodes from one data center to the other, or they may detect the bad node in the background to replace it. So all those things can happen, and it's very frequent for super large clusters. It always happens. It never stops, and usually like Pinot's admins do not need to care about it, and this can happen fully transparent to our system.
Got it. Okay, that's cool. So and then in terms of like download phase, it's not require any Helix transactions. It's more like you look at the ideal state or something, and then decide where to fetch all the segments.
Yeah, exactly. So how it works is kind of it has a mini ZK client to read from the ideal state and then download it. And because it's using the same server configs from the because it's same server config, and it can use same Pinot library, so everything should be same, and it's kind of fully backward compatible.
Got it. Okay. So and then do you think like so I heard that you're using like the kind of something like a pre-container to do all those things for now. Do you feel it's actually possible to make it part of the startup process?
Yeah, I believe so. So right now, how it works is we can use some, for example, environment variable to control like how we start a container. And certainly one improvement, as what we mentioned, is we can just start a container and try to join the Helix cluster. And for example, if it cannot join, find is there's already something taking it, then it's doing the pre-download. So after pre-download, then we try to fetch something because we need some sync between the new node and old node to understand like when the new node pre-download complete, then we shut down old node. So there need to be some sync. Right now it's happening on the underlying host agent to sync between two node status. But we can try to make it within Pinot. That's possible.
Yeah, makes sense. It's kind of like say maybe for example we can add another status for let's say the instance and say the instance transition may go from like start, go from like the offline to init, then init to online. And then what you can do is like for the state transition or something, you can actually let it download the segments without touching the helix transitions, and then then you go to the next step. Yeah, I think in the real in another like cloud vendors like AWS, we also say that just pulling data from like S3 and decompress that is actually super fast. You can actually go like extremely high concurrency and pretty much like a max your network for download part.
I see. Yeah, we also did some benchmark because we are not using S3. We are seeing this is not that fast based on some benchmark, but this can vary based on your segment setup. If you have super large segments and you have complex index, then this kind of loading and decompression will also take some time. But it kind of varies based on your environment. Yeah.
True. So in terms of that, we do like, let's say if my remote segment is just the raw data, and then later on in the table config I modify or like add some like derived columns or the index in the preface, in the pre-download phase, are you going to like create this index at the pre-download phase, or you will still rely on the server startup to create those index?
Right now it's based on the server startup. It's currently is only downloading data and decompress.
Download
data.
and decompress.
Yes.
Makes sense.
Yeah.
Cool.
And yeah, just we already updated the Apache doc with this Graceful no replacement setup. So yeah, if you are interested, then you can refer to this page and set up your environment.
Yeah. Sounds good. Yeah, because we were also like thinking of how to make it like more like in an efficient way. We even think of like how we can do like rsync from server to server for the disk side, but apparently because the server side thing is like it may be like differ from like each other. So the real download part is actually from my observation, it's like downloading from S3 is much more faster than comparing to download from other nodes.
Yes, and once you've downloaded those segments, it's not like not a perfect swap, because the old node still had those segments loaded in memory, right? And we're starting with a new node that has nothing in memory, right? So there still also has to be a part of like warming up the new node with the same memory for that use case. There's like could be a small like query performance hit as like the segment data gets mapped during those first few requests. But there was another talk at Uber that also touched upon that topic as well, like doing a warm up of the new nodes.
Yeah, that part I think is more like a server restart overhead. So right now there are some many memory loading thing happens after the startup. But theoretically, it's possible that we do this memory loading during the node replacement, like so-called pre-download phase. That's also possible, but it's kind of like a next phase. Yeah. Yeah, if no questions, I will hand over to next.
Yeah, let's get 2 minutes back to Shaurya.
Yeah, hey, yeah, I can start sharing my screen. And yeah, let's deep dive into this. Yeah, thanks for joining, folks. I'm Shaurya. I've been working with Uber for 6 years now, and like in the Pinot team for a year now. And how I joined Pinot team was basically my previous team needed an integration with Pinot. We were replacing a proprietary database for our like large scale table joins and like real time analytics. So like that was how I was introduced to Pinot, and I found Pinot pretty fascinating, so I just switched over to Pinot and like learning here and contributing. So yeah, that's just some context about myself. Today I'll be talking about the Timeseries Engine GA in Pinot. And yeah, I can go ahead with like the agenda is pretty simple. Like we'd be talking about like what like I'll be explaining what the Timeseries Engine is in brief and the core components, and then like what's the GA timeline for Timeseries Engine, and like what all are we planning to add, what has been added yet, and what else are we planning to add like in the future iterations for time series. So Timeseries Engine is like a very specialized, query engine within Pinot, which helps us to query metric style, queries essentially. So that would mean that if you've ever used like PromQL or M3QL, like those languages are very intuitive in writing time series based queries where, for example, you would want an average, moving average of like CPU usage or like say bucketed request latencies over some period of time. So essentially, Timeseries Engine is like the extension which is built within Pinot to help answer those queries without writing awkward SQL queries, which would involve a lot of select with the time series columns, and then you have to do all sorts of transformation, which is not very intuitive when you write with SQL. So like basically the core components of time series engine is like, firstly, we have the query reception and parsing. So this flow, the whole flow is actually built adjacent to the current single stage engine and the multi-stage engine, but we do reuse some parts of it. But essentially, like there's a separate time series request handler which starts basically is the entry point to the time series engine. The query reception and parsing basically takes the there's a Prometheus compatible API which we use to trigger the whole time series engine query flow. The query reception parsing logic basically passes into a standard range time series request object, and then this standard object it goes through two phases. Like first is the logical planning, and then is the physical planning. In the logical planning, this is like dependent on the language which you're trying to support for the time series engine. So like the implementation for time series engine in Pinot has been written in such a way that any time series query language can be plug in and played. So that would happen within the logical planning. So that range time series request would have a SQL, like would have the query string attached with all the other parameters like start time, end time, and like the steps which we want to take basically between two time stamps. Basically also the resolution, and the logical planning would basically be implemented for each of the languages which query languages which is trying to support. And this would basically convert that query into an abstract syntax tree, and which will basically be created using the base time series plan node. So once the logical planning is done, the physical planning comes into the picture, where this abstract syntax tree is converted into an executable plan. This the workers to execute this query is assigned, and then like there's a query dispatcher which is created, which basically transforms the query into time series query request, and it is broadcasted to the servers like which are involved for that particular query. Within the Pinot server, there's a separate endpoint time series query. Like it's separate from the single stage engine, and this is like tangent flow, which basically first decompile, like basically after marshalling the time series query request, it compiles it into an operator chain. That operator chain is executed within the server itself. All the table scans, the aggregations, and the transformations take place within the server. and the aggregated results are sent back to the broker, like sent back to the query dispatcher, and then the results are compiled in the broker and bubbled up to the user. So it's a pretty regular flow, just like single stage engine, but basically it's a tangent flow here. Yeah, sorry. Yeah. For the general availability timeline, so in Pinot 1.3, the Timeseries engine was released as experimental. So at this point, there was a Prometheus compatible API, and like it had limited support for sophisticated cases within time series, but like it was still functionally complete in a sense that end-to-end queries could be run, like time series queries could be run, and in Uber, actually, we have been using, in Pinot 1.3, we have been using Timeseries Engine to actually power a lot of observability use cases, especially cases where high cardinality is required, because that's like one of the uh, core strengths for Pinot to serve. And then like with the upcoming Pinot 1.4, we are planning to release the Timeseries engine in beta. So in beta, we have some of the changes which we made till yet. So we have the controller UI, we have the auth and security introduced here, and also we have made some quality of life fixes like not especially mentioning the table type while querying the table. Like it automatically will detect like what table type it is. And then Pinot 1.5 is the version where we are hoping to make a time series engine generally available. That would involve, introducing a broker compatible API, and also, adding more support around, query event listeners, query options, and explain plans. So I'll be talking about that later. But this is the current timeline which we have for the time series engine. Yeah, so for what's new, basically, like one of the flagship things which we've introduced in the 1.4 is the new query UI and controller. So this is a brand new query, brand new query UI, which basically can directly, power the query which you want to run. Earlier, before this, like you would have to basically set, like in the quick start, you would have to simply make an API call, which is again not intuitive while visualizing the time series data, because the time series data is basically a lot of timestamps with the relative metrics, bunched in. So this UI actually helps visualize the time series data much more intuitively. And this basically contains the query language, the start and end time and timeout, right? So this query language is again dynamically populated from the backend, and one controller can support multiple query languages based on like what query languages do you choose to plug in. And then within the time series panel, this is powered by the Apache eCharts, and this supports like mechanisms like zoom, pan, and hover. And also like we can select a single series to basically clarify, which series do we want to investigate further. And also it also supports like truncation for higher number of series. So there might be a case where the cardinality of the series is very high, and which might affect, the visualization process. So we also have a built-in support to truncate like the high cardinality series. And all this I will be showing in the subsequent demo. And then like the second important thing which we are introducing in the time series engine is the like broker compatible API. So the current API, which is Prometheus compatible, does work well. For Pinot, it's not the best, best integration, because like there are several things which are missing, right? Firstly, like it does not really fit into the existing broker compatible response structure. So it's difficult for the end user to basically reuse the same parsing object for a broker which they have for time series query. So basically there would have to be an entire different response, and that basically is like one of the drawbacks of the current Prometheus compatible API. The second thing is also the current Prometheus based API does not support Pinot query stats. So like, and these stats are pretty valuable when we also want to find if the result which we have is truncated, or like how much time did it take in which each stage. So hence the like broker compatible API is something which is pretty important, so that like this time series like the engine can actually be more Pinot like here. So this is still under development, and yeah, this is something which we'll be introducing soon. And then security on authentication. So Pinot already has a built-in authentication system built in, which basically filters at two levels. One is the requester level access, and the other one is the table level access. So that access has also been extended for the time series queries, so that like we can uh, authenticate and we can manage the access for like at a table level for the time series queries as well, which was not present in the 1.3. So let's talk about what's next. Firstly is the integration with query event listeners. So right now, again, the query event listeners are only supported for the single, the SSC and the MSC queries, but not for time series. So once we have the broker compatible API, where we can actually fix the firstly the response structure and also the query stats integration in time series, we can then easily integrate with the query event listeners as well, which would help in traceability and also future like any like you can link it to, at least in Uber, what we do is that we link this query event listener to a Kafka topic, and we dump that data into a Hive table so that we have long-term retention on like the query event stats, and then we can also do some kind of analysis on top of it. Then the second thing is we would be supporting explain plans. Now, given that the each query language would have their own semantics, we are planning to support the explain plan as a query option, so that like it is like, even if the language itself does not support like explain as a keyword, we can still show the what the explain plan can be. And this explain plan would basically be the abstract syntax tree which is being created, so that like it's easier for the plugin developers also to clearly understand what kind of abstract syntax tree is generated for the particular query after the logical planner phase. And then like the third is the supporting query options. Like I think this is we already have that in the SSC and MSC queries, and right now in time series we don't. So this is also a future plan for, and again this is because each query language can have their different custom options which we need to handle and pass in. So query options would really help us do that. Then hybrid and logical tables support also needs to be added. This is not a blocker for the GA, but this is like something which we want to support soon. Since like these are also being evangelized more in Pinot, so we would want to extend the support for time series as well. And then finally, evaluating the exemplar support. So what exemplars are is basically for a time series data, we sometimes what happens is that we want to investigate individual traces for data points which are like very exemplified from the current trend. So for example, if I have like a metric for the latency of an API across time, there might be some tail latencies which are like super high, and we want to identify which queries those are, so that like we can easily just debug like what is like different with them. So for those kind of queries, exemplar is basically the link between the metric and the individual trace, which is an outlier from that. So this I think is currently supported in Grafana, and is something which we also want to support for Pinot. Like this is still in an evaluation state, but this is something which we are also considering next, so that like it's even easier for us to integrate production level metrics and observability within Pinot, and like it's easier to debug any production incident which is powered through the metrics which is presented like within the Pinot. So before like the Q&A, I'll start with the demo actually, to show what the controller UI looks like. So basically in the controller UI, we have like within the query console, we have the two new bifurcations now. The SQL query defaults to the regular SQL query, and the time series query is like where you can add your time series query. So we have integrated the M3QL currently in open source, and this is like you can access it like this. So let me just run this. So you can see that like this is an Apache eCharts visualizer, and basically you can see the this supports like the hover mechanics to see like the value at each point for each of the series. And then we can also isolate any series like by selecting it, so that like you can investigate deeper into a particular series. And then this also supports zoom mechanics. Either you could use the selection to zoom it out and reset it, or you can use your scroll bar to do that. Future additions, and also, sorry, to mention, we also have the raw data which we can see. Like this is the Prometheus compatible API response which we have. And this query language is again dynamically populated. Since in open source we just have the M3QL plugin right now, it just shows that, but any future extensions can be automatically derived from this tab. And then I think a few more additions which we want to do is like instead of making this Unix timestamp, we want to use a date time picker because it's more intuitive to add it here. And also like for so for example, if I change it to some let me just find a high dimension query. So let's take event ID, for example, right? So we can also see that like if there's a high if there's a high cardinality, we truncate the series to, right now it's like hard coded, but we are also planning to move this as a user configurable input, so that like each user can do it at their particular preference. So yeah, let's move to the Q&A. Any questions?
That's a great presentation, Shaurya. Really excited to see Timeseries Engine being developed. You mentioned in the next phase the added support for the explain plans. Would those explain plans be specific to like the particular time series dialect, like M3QL, or would they be like more generic, like applicable to any time series engine or
Yeah.
dialect?
Yeah, that's a good question. I think what we are hopefully aiming for is something which is very generic, because ultimately, I think with explain plans, we want to get an idea of how the query is being executed within Pinot, and like having different explain plans for different languages might, not be an ideal solution, given that it would basically introduce more complexity, like when you are basically handling across different time series queries and languages. But having said that, I think we would have to evaluate this at what level is it feasible for us to show the explain plan. So I think that's still an open question which we are still working on, but hopefully I think the direction here is to like implement that agnostic of the language, time series language which we have. Yeah, I think I see one question here is that can you elaborate on how the new controller UI improves the query building experience compared to the previous interface? So yeah, I think previously in 1.3 we did not have a UI. So like all the testing and all the query building had to be done within like by making a curl call to the existing time series API, which was a little more unintuitive because like the command line like the output again is like something which you cannot visualize on a graph directly. So that would have involved users building their own time series visualizers on top of it. But with the new controller UI, it's more intuitive to actually see the metrics which you are going to use in production. So that is like how the new controller UI actually helps with the visualization and the query construction as well.
I see. So I also have one more question. It's like, for example, how so let me just ask from like the user side. Let's say if I want to integrate Pinot with, let's say, Grafana, what kind of the process for this?
I think for that, I'm not sure like the controller UI would come into picture there. There we would still have to rely with the Prometheus compatible API, which is currently existing, right? So we have actually integrated like Grafana with our Pinot, but it's through a proxy service which is internal to Uber. So it's not a direct integration, and I think it would be a similar integration just like other data sources. So there's nothing special there, uh, like compared to what it is right now. So I think that would basically be my answer. I don't have the specifics there, how we could integrate Grafana, but I'm imagining we can simply use Pinot as another data source
Data
with,
source, yeah.
yeah, a simple data source with, like the existing API, or actually like in the future, we could also directly use the new API. But I would imagine like at least for external integrations, the current Prometheus API would actually be more compatible since it's a standard format. So like other visualization tools would already have the parsing logic built in for that one.
I see. So basically it means that we already implement like all the promises all the Grafana require the promises API, which means that we can treat probably Pinot time series engine as like promises kind of backend.
Yeah, yes.
Okay. Yeah, I think that's a good thing to give it a try. And your connection will just be the Pinot controller, or it will be something else.
I think the connector can again. I think the connector would just be responsible for discovering the broker and hitting the correct broker, right? Or actually, we can also use it from the controller. I think right now we are not, but like since there's a API and the controller as well, which is powering the UI, you can also directly use the controller.
Just use the controller. It will be like probably more hops between if the request goes to controller, then broker, then server, then coming back. But
Exactly.
it's probably okay for like the visualization as long as it's not like super high QPS, those kind of use cases.
And
Exactly.
you're also saying that your internal proxy service between Grafana and Pinot is not required because of the broker API compatibility with Prometheus?
Yes, I think that is true. I'll again have to double check. But yeah, I mean, for us, I think that a proxy service does a lot of other things.
Yeah.
Like just, but I think theoretically it is possible for like the Pinot like API to be directly plugged into Grafana as a data source.
That's cool. Yeah.
Cool. If there are
I,
no other,
I, I I had one more question
uh,
regarding the user and again going back to the original Gen AI topic. If you're using and which services or models you may be using for generating M3QL syntax, queries. If you,
that's a good question, but like I don't think like we had that like problem yet. I think M3QL queries by design are very intuitive to write, and I mean, me personally, I haven't used GenAI yet to generate these M3QL queries because these are generally very simple in nature. Like you just need to
yes.
set the table and a couple of aggregations, and I think mostly you've done. If it's like much more complex than that, then it kind of warrants its own metric to be emitted. So yeah.
So you haven't had any like cases where the M3QL, right, is very complex and hard to kind of read and reason like someone like me who's more familiar with or working with SQL. So
Yeah,
that's nice to
not yet.
hear.
Yeah, we've not had those cases yet, but I could definitely imagine that happening. But like it's again like it's simpler than SQL. Honestly, like if we visualize like the time series, like for time series data, I think MCQL is much more intuitive, and like generally it's much easier than writing the SQL which outputs the same result.
All
Cool.
right. So Yeah, so yeah, thanks Xin and Shaurya for the great presentation, and also thanks for everyone who were joining, and we'll see you in the next Pinot contributor call. Cool. Thanks everyone.
Thank you.
Take care,
Yeah.
guys. Thank you.
Take care.
Thank you.